in internet. But today we have something very interesting, that is an article published on audit done with the will of the company. I think that's really a landmark on auditing algorithms. This is a case on candidate screening, a company called Pymetrics. And I'm sure, as me, we are all eager to learn from this experience. Christo, the floor is yours.
Thank you, Ricardo, and thank you everybody for being here. So yeah, today I want to talk about this audit that we conducted of this hiring startup called Pimetrics. So this was published at FACT 2020. So yeah, I'm Krista Wilson. I'm an associate professor in Khoury at Northeastern. I also have an affiliation over at the Berkman Klein Center at Harvard. As a researcher, I wear a number of hats. Some of my work is primarily focused on things like online tracking and privacy. I do some more classical applied cryptographic work on things like TLS. But really the bulk of my time over the last 10 years or so has been on this auditing algorithms stuff. So as Ricardo mentioned, historically, almost all of the auditing work I have done has been as an outsider. So we're looking at an algorithm or a system deployed by typically a big tech platform, and we're asking critical questions about it. You know, what is its role in society? What can we learn about this system and how it functions and its impact by kind of poking and prodding it? So to give you a sort of flavor of the kind of audits we've done in the past, a lot of our work has focused on things like filter bubbles and political information. So we look at systems like Google Search or now YouTube to see, are they spreading misinformation or conspiracy theories or heavily, partisan biased content? Is it being personalized? How are ranking and filtering algorithms dealing with this content? Another area that we've spent a lot of time looking at is marketplaces. So these are things like personalization of prices and products on e-commerce sites. We did a study looking at Amazon's buy box algorithms. How do they choose which seller among many will be the one who actually provides products to you? And we've done things like reverse engineer Uber and Lyft's surge pricing algorithms to understand if they're actually responsive to supply and demand or whether they're really just price gouging people. So another area of great interest to us are things dealing with bias and discrimination. So we've done things like look at gig economy platforms where you can go and hire people to do work for you to see whether they are impacted and their algorithms are promulgating racial and gender biases. We've done similar things on resume search engines. So if you're a recruiter and you're searching for, I don't know, a software engineer in Boston, right? What kind of information is that search engine presenting to you? And does it have any sort of latent bias embedded into it? So I can give you a quick example of one of these bias and discrimination studies that we did in the past. So this is a study that we did of Taskrabbit. So this is a gig economy kind of service where, let's say you need someone to paint your deck or walk your dog. You go and you search for a worker, right? And there's this search interface where they will say, here are some people who can do that job, who live near you and are available. So one of the things we looked at on Taskrabbit was whether the social feedback being left on the workers exhibited racial and gender biases. Right? If you look at this screenshot, you'll notice that the workers can be rated and reviewed. And we found that indeed there were correlations between the feedback that workers got and their demographics. Right? So in particular, if you were a woman, especially a Black woman, you tended to get less feedback overall, and that feedback was either more neutral or actually more negative, versus say if you were a white man, you tended to get a lot more reviews overall, and they tended to be more effusive and positive. So this is a clear example of a social bias, right? People have these latent biases. They show up in the way they review the workers, and then that appears on this website. It's disturbing, but it's also not entirely surprising. What was more surprising was when we looked at the search engine itself. So if you look at the correlations between the worker demographics and the order in which they appear in the search results, we saw that these correlations held up again. Right, so this screenshot was actually representative. White dudes tended to appear more highly ranked in the search results. Eventually, the company sort of admitted to what we thought was going on. The workers are being sorted in part based on the social feedback, right? And that sort of makes sense from an engineering perspective, right? You have to rank these workers, who should go at the top? Well, it's the 5-star workers, right? They're the best, so they should go on top. But they failed to consider the source of that data or any sort of latent biases that it contained. So, if you follow the news, there's pretty widespread recognition at this point that these systems that use machine learning and artificial intelligence, right, they can go horribly awry, right? There's all these documented examples of problems in these systems. And so I would argue that algorithm audits are one part of a comprehensive solution to these problems, right? It's not the only part of the solution, but it is part of it. Right? So the idea here is that the algorithms that are being used and the data that are being used in these different scenarios should be vetted, ideally by an independent expert. This helps to increase transparency, right? If you release the results of the audit, it tells you things like, how has the system been built? What, if any, fairness objectives have been embedded into it? And then how have those objectives been validated based on this independent assessment? Hopefully, if this is done well and it's done transparently, this also increases accountability, right? You can no longer hide problems in your systems. You can no longer say, well, this is all just a trade secret, we can't talk about it, right? If there are problems, they will be found, they will be aired publicly, and hopefully addressed. So, again, historically, the work that I've done in this space has all been done as an outsider, without the permission of the company. In some people call this a permissionless audit, right? We're essentially doing black box reverse engineering, typically violating someone's terms of service. And that's good, right? We should have this completely outsider style audit. But an open question for us was, could you actually work with a company to do one of these audits? Right? What would a permissioned audit even look like? So prior to this work that I'm going to talk about, no one had really done this sort of thing with a company before. So that brings us to Pymetrics. So Pymetrics is a startup in New York, and they offer a candidate screening product based on machine learning. So I'll tell you a little bit more about how their service works and what it does. But the high level is that, let's say you want to recruit people, right? Those candidates would apply. They would play some games that Pymetrics provides. And then Pymetrics has machine learning models that would say, these are the people who we think are good candidates for this job at this company based on the gameplay results and the models that they have trained. So they're one of a number of startups in this space that do candidate screening based on a variety of different kinds of data, different kinds of models. So one of the things that Pymetrics has been very vocal about over time is that they claim their systems are fair. And this is what sort of brought them into our orbit. So in October of 2019, they approached us about having us do an independent audit of their system. This was extremely interesting to us. We had been thinking about whether we could do this kind of cooperative audit with the company before, and we hadn't had an opportunity. And Pymetrics was a particularly good case study, we felt like, because they operate in a very regulated space. So there is a lot of regulation about how hiring can and can't be done to mitigate historical discrimination problems. So this is a case where the company is operating in an environment where there may be clear baselines to assess whether their systems are sufficiently fair or not, which greatly eases the process of doing the audit. So, Pymetrics had made these claims about their system being fair. They'd actually released some open source code about how they do fairness testing, but they hadn't gained much traction. I don't think people really believed these claims, despite the fact that this code was open source. And they wanted an independent evaluation to say, these are the claims they had made about their system, and those claims are true. They are fair with respect to some criteria. So this, was very interesting for us, and we agreed to do this audit. So I want to tell you about the results of this audit and some of the things that I think are unique about it. So on one hand, I think we make some technical contributions. So I'm going to tell you how Pymetrics actually implements adverse impact testing in this system and how they believe it meets legal requirements. I'll talk about the process we used for our audit. And obviously, I will tell you the results of the audit, right? So did they pass? But I also think this study has some broader impacts. This is one of the first examples of a cooperative audit, right? We worked with a company to audit their product. We were given insider access. And so I'm hoping that this can be a model for future audits in this vein. So our process is fully documented. It's extremely transparent. And I'm hoping that this can be a playbook for future audits of this type. So here's kind of the arc of the talk. I'm going to start by telling you about Pymetrics. So what is their product? What is their machine learning pipeline? What does the data look like? And what are the fairness criteria they're using? Then I'll tell you about how we designed our audit and some of the key challenges we identified. I'll walk you through the audit results, right? So exactly what did we test for? How did we test it? And what did we find? And then just some takeaways. So let's start with Pymetrics. So Pymetrics' claim is that their machine learning models can achieve rough predictive parity based on the 4/5 rule from the US's uniform guidelines. So this is a guideline from the UGESP organization that's part of the US government. And it can be roughly defined as the following, right? So the pass rate of the lowest passing group of your process divided by the pass rate for the highest passing group must be greater than 0.8. Right? So essentially, you're allowed to have this 20% sort of margin of error or disparity between the different groups looking at the outcomes of your hiring process. Right? So this was designed a long time ago. It wasn't written for algorithmic hiring systems, but it is now being applied to them. In terms of who this applies to, the uniform guidelines talk about this in terms of gender, race, and ethnicity categories. These categories are woefully out of date, right? So that's just talking about men and women and basically census categories. So this is arguably not a great framework, but it is the framework promulgated by the US government. So this is the framework that Pymetrics has chosen to adopt. They say their models meet or exceed the 4/5 rule. How they do this, roughly, is the following. So they claim that their model training process produces the least biased, most predictive model for a given job, for a given client. So roughly what's going on is that they train models without using any demographic data. So the training process is demographic blind. Then they evaluate those models using a held out set of data that does have demographics. So essentially they're playing a hypothetical. Right? If this held out set of people applied for the job, how would they be evaluated and would it meet the 4/5 rule? Then they go back and based on the results of that analysis, they perturb the features to the model, they may remove ones, they may add ones, and then they iterate. So they go back and they train more models, they reevaluate them using the held out set, and they keep going through this process until they find a small set of models that are both highly predictive, but also meet the rule. And then they choose the one that is essentially the best balance. Some of this code that they use for this is open source. You can find it on their GitHub, but not all of it. So you may be wondering why Pymetrics chose the 4/5 rule. This was very much up to their lawyers and their interpretation of US case law. So the 4/5 rule isn't really a law, right? It's a guideline that's promoted by the Equal Employment Opportunity Commission. Now that said, it's a guideline from the EEOC, so it is taken extremely seriously, and it is accepted by judges, right? So there are employment discrimination cases that turn on whether someone was discriminated against, and then the company says, no, we're following the 4/5 guideline, and the judge says, yes, that is sufficient. There is no discrimination here. Furthermore, why did they choose just these racial and gender categories? Again, this is based on the EEOC's guidelines. So in Pymetrics' interpretation, if they tried to make their system fair for other groups, in fact, including intersectional groups, that might not actually be legal because they are not specified as protected groups under these guidelines. Now, I mean, personally, I think the 4/5 rule is just a terrible rule. It's woefully out of date, and the groups for which it applies are far out of date. They clearly need to be updated. But Pymetrics' stance is that adopting this guideline makes their system legal and will enable them to survive lawsuits. And so that's why they've adopted it. So let's talk a little bit more in detail about how their actual system works. So the product that Pymetrics is providing is this machine learning powered candidate screening service. So ultimately, decisions for who should be interviewed are based on these gamified psychological assessments. So Pymetrics has this suite of little games that you play either in your web browser or on your phone. And that data is ultimately what's being used to make predictions. So what does this whole pipeline look like? Right, so let's say there's a client that wants to work with Pymetrics, right? They would have a contract with Pymetrics, and they would say at the outset, we want to hire people for a specific kind of job. Like, I don't know, we're a bank and we want to hire salespeople. So at this point, the client needs to provide 2 data sets about their incumbent employees to Pymetrics. So let's say you want to hire salespeople, you would provide performance assessment data about the existing salespeople, right? So this could be their sales numbers, right? If it's like you want to hire programmers, it could be things like the number of lines of code they produce, or this could be qualitative performance evaluations. Whatever it is, you're providing performance data. And then the incumbent employees need to play the Pymetrics suite of games. Right, so this data set goes into the model training pipeline. So then this data from the client, right, the performance data and the gameplay data, that's essentially the positive labeled training samples for the model, right? These are the existing employees, you have their performance data. This is what the model should be predicting for in the future. Right, so all the negative training data is drawn from Pymetrics' historical gameplay records. Right, so they have had millions of people play the games in the past. They take a basically random sample of that, and they say these are these are examples of other people who played the games. Right, they shouldn't be hired. Right, they're the negative training data. So at this point, there is no demographic data being used. Right, you just have the gameplay data, you have the performance data. That's it. So the models that come out of the training pipeline then get tested for adverse impact, right? So do they meet the 4/5 rule with respect to gender and these racial and ethnic categories? This is done using a held out set of gameplay data that does have player demographics. So again, this is sort of a hypothetical process. If these people were to play the games and then be evaluated by this model, would the results be fair enough according to the 4/5 rule for men and women, and then for, I think, 5 racial and ethnic categories? This process is iterative, right? So based on the results of the adverse impact test, they will go back and they will perturb the training process by adding and removing features. Then they go and train more models, right? Those then go back in and get tested for adverse impact again. And this keeps going around for hundreds, even thousands of iterations. Okay. Eventually, right, a Pymetrics data scientist will look at the outcome of this iterative process. Their job is to pick the best performing model using your standard kind of set of performance tests, as well as the model that is most fair. That's the one that ultimately gets deployed into the field. right? And again, that assumes that they can find a model that at least meets the 4/5 rule. If they can't find a model that meets the rule, then all bets are off, right? They go back to the client and say, we need to start over. So the best performing, least biased model gets deployed into the field. At this point, the company can advertise the position. Right? Candidates submit their resume, but they would also play the Pymetrics games, be evaluated by this model, and then the highest performing candidates, based on some cutoff criteria, are then sent to the employer for them to evaluate, and they can interview them. Crucially, when people are playing the games, they're also offered the option of taking a demographic survey, right? And that data all gets fed back into the pipeline for future client engagements, right? So the people who are being interviewed for jobs now, their gameplay data could be used to train models for future clients, right? And then people who opt into the demographic survey, they can also be part of the held out set that's used for adverse impact testing in the future. Pymetrics reported to us that over 70% of people who play the games also take the demographic survey. And it didn't appear like there were any demographic biases in terms of who completes the survey. So I would say that that demographic data linked to the gameplay data is actually pretty solid. So the focus of our audit is here. It's this orange box, right? They claim they're doing this adverse impact testing, that any model that comes out of the pipeline meets or exceeds the 4/5 rule. Right? That's what we're coming in to evaluate. So now let's talk about how we designed the audit. So right off the bat, we knew there were going to be some key challenges. One of which is establishing the scope of the audit, right? So what is it that we are going to be testing, and what is it that we're not going to be testing? So we can be extremely clear about this. The other facet is maintaining our own credibility, right? We're now cooperating with a company, which is unusual for this kind of work. What can we do such that when we eventually produce the results of this audit, that people will believe the results? So with respect to the scope, right, what did we choose to test? We identified 5 things ahead of time that we thought we could evaluate sort of on time, on budget, with the expertise that we had. So we looked at correctness, and this is basically, does Pymetrics' system match their claims? Right? They claim it's meeting the 4/5 rule using this process. Does it actually do that? The second thing we looked at was direct discrimination. Right? So they claim that their model training process is demographic blind. Is that actually the case? Third, we wanted to look at socio-technical safeguards. Right? So Pymetrics' process is not fully automated. Right? There are data scientists involved. They can tweak things. They look at the final models to evaluate them. So are there opportunities here for human error? Right? If a data scientist fat fingers something, or even if there's a malicious data scientist, what safeguards are in place to prevent malfeasance? 4 is debiasing circumvention, and this is really adversarial machine learning. Right? Part of the data that's being supplied for the model training comes from the client. Could a client intentionally supply malicious data in an attempt to get Pymetrics to produce and then release a biased model? The 5th thing is sound assumptions. Right? So like any model training pipeline, there's a bunch of data cleaning and munging assumptions that happen at the very lowest levels of their pipeline. Is there anything that's getting baked into that potentially then leads to bias that you wouldn't detect downstream? So just as important as the things that we did want to look at are the things that we're not going to look at. So what did we rule out of scope? One of the things that was out of scope is the definition of fairness. Right? So I talked about these legal reasons why Pymetrics adopted the 4/5 rule. I'm not a lawyer, and we didn't feel like we were in a position to question their choice of fairness metric. So we just accepted that 4/5 rule would be the metric that we were going to be assessing towards. The second thing we didn't look at is predictive validity. Right? So Pymetrics is using games to assess people for employment. We did not investigate the validity of the games as psychological constructs for employment evaluation. Is that a reasonable thing to ask? Absolutely. but again, we did not feel like we were equipped to assess that question. We didn't look at any Pymetrics products other than this candidate screening pipeline. And this audit didn't look at anything related to cybersecurity or privacy. It's just, that was not that kind of thing we were looking at here. So what did we do to actually maintain our own credibility? One of the first things that we had to grapple with is, would we be paid for this? We could have done the work pro bono. On one hand, I very much feel like if we had done the work pro bono, that would have really led us to say, like, yeah, we're truly independent here. On the other hand, we really were uncomfortable with setting a standard where the only way you could do an audit with a company would be to not take payment, because this is like hard work that requires a significant amount of expertise, and especially since we were having students involved in this, we were very uncomfortable with setting that as the standard. So ultimately, we were paid. This was a contract through Northeastern, so it was structured as a grant. But all the grants and all the contracts that we signed are all public. And so you can see the way they were written, all of the money was given upfront, and it was not contingent upon results. We pretty much could have walked away with the money, and there's nothing they could have done about it. Secrecy protocols. During the audit, we were meticulous about not revealing what we were testing or how we were testing it to Pymetrics. So to a certain extent, we had to ask them for things like specific data sets. But we had all these very awkward meetings with them where they were explaining things about their process and their code, and we're basically sitting there in silence, not wanting to tip our hand about anything that we were or not were not particularly interested in. One of the crucial things is that we retained the right to talk and write about the audit. So the only things that I'm not allowed to reveal are basically their source code, their data, and some particular things about their pipeline, like really detailed technical minutia that they view as their intellectual property. Everything else we can talk about. If they had failed the audit and were doing terrible things, we could talk about that. We did agree to a 30-day responsible disclosure period. This is something I actually added to the contract. And this is basically from cybersecurity. If we had found something terrible in their system, right, we basically said we would report that to you privately. We'd give you some time to correct that issue before we would go public. So in terms of transparency, we are as transparent as we could possibly be in this project. All the contracts that we signed, the budgets, that's all just sitting on my website. Obviously, the paper that we published is public. There's also a white paper version that we prepared just for Pymetrics. That's also public, minus one or two redactions. That's on my website. You may be curious about the authorship of the paper. Right? So it's co-authored by us and Pymetrics. So basically, Pymetrics wrote most of section 3, which is the part about their own systems. They also contributed some of the takeaways, but everything else was written by us. So now let's get into the results of the audit. So if you recall, there were 5 things that we wanted to look at. So the first is this correctness issue. And this really just boiled down to us manually looking at and running some tests on their source code. Okay, so they claim they've implemented the 4/5 rule. They claim they have this iterative pipeline. Does it actually do those things? And it does. I mean, we found the code. It was all a bunch of Python. I mean, it was very readable. We ran the pipeline ourselves. It does what it claims. So yes, I would say it is correct in implementing the 4/5 rule. Was there direct discrimination? So the answer here is no. I mean, we went through all the data that was being ingested, looking at the fields, right? There was no demographic data that was going into model training. So there was no direct discrimination here. In terms of the socio-technical safeguards, we were actually pretty pleased by what we found here. So for every client engagement, they have a data scientist who sort of leads it. It's all just in one big Python notebook per client. That data scientist, before they can turn in the final model, has to complete an extensive checklist where They have to document all the decisions they made, all the key accuracy and fairness metrics, any deviations from the usual protocol. So there's this extensive document they have to produce. That all gets checked into their systems, and then another data scientist chosen at random has to go through and double check the whole thing. So what's in the checklist? Does it match what's in the notebook? Just double checking everything. Only after the second data scientist has done that can a model actually be released into production. So is this a perfect system that precludes an erroneous model ever being deployed? No, it still involves people. But in our opinion, this is actually a pretty good system of documentation and review. It seems like it's good enough to stop any sort of unintentional error. And if there was like an evil data scientist who wanted to release something bad, you'd have to have at least 2 people collaborating to get this thing through review, which seems like a fairly high bar. So now let's talk about the debiasing circumvention. So this is, again, basically adversarial machine learning. So the attack scenario is the following. Right? Let's say there's a company and they want to intentionally hire a homogeneous set of employees. Right? It's a bunch of white dudes, and in the future, they only want to hire more white dudes. Right? Their company is supplying data to Pymetrics that gets used in model training. So what if that company supplied false or fabricated data? Right? They could say, oh, we have a very diverse set of employees, when in fact, really, it's a bunch of white dudes. They could say, yep, all of our employees played the games, when in fact, really, it's just one person playing the games over and over again. Right? There's a variety of ways where they could fabricate data. If they did that, could they get Pymetrics to produce a biased model? So we essentially were playing the role of the attacker here. Right? We produced artificial data sets that were hugely biased. We took their existing data sets and subsampled them, right? So we would just pull out the white dudes. We did things like clone one particular white dude and just supply them as training data. We took one particular white dude and just perturbed them, right? So it's me and then me with a mustache, me with glasses, me with a mask. So we threw these a variety of intentionally biased data sets into their pipeline to see what would ultimately happen. The outcome is that these attacks failed, and there were really 2 different failure modes. So sometimes we would give it a really biased data set, and the training pipeline could not find a model that would meet the 4/5 rule. Right, so at that point, their data scientist would say, we can't make a model, and they would actually have to go back to the company and say, there's something fundamentally wrong here, we need better data from you. So that's a failure. The other thing that happened is the model training pipeline would actually succeed. It would find models that were both predictive and met the 4/5 rule. So essentially, even though we had supplied intentionally biased data, the training pipeline was able to find enough features that were predictive and not linked to demographics that it would still find a model that worked. So that's also a failure, right? I'm trying to get you to only hire a homogeneous set of people, but now Pymetrics is deploying a model that is unbiased up to the 4/5 criteria. So this was interesting, but also kind of expected. And the reason is that the client in this case is supplying biased data at training time, but they have no ability to influence the held out set of data that's used for bias evaluation. Since they can't mess with the evaluation set, that actually prevents these kinds of attacks from succeeding. So the last thing we looked at was this issue of sound assumptions. So is there anything in their, embedded deep in their pipeline about the way they're cleaning their data or sampling their data that could lead to downstream bias? So one of the things that we ended up focusing on heavily was imputation. So like many data sets, their gameplay data is not complete. There are cases where someone might play only a subset of the games, or they might abandon a game part of the way through, so it doesn't have all of its features available. but you can't feed a data set with missing values into the training pipeline, right? So missing data has to be imputed. So at the time, Pymetrics was just using a median imputer, and this struck me as potentially problematic. So we looked at things like, is the distribution of missing traits correlated to demographics? And we found that it was. So in particular, people who identified as Black tended to have slightly more missing values than other players. The other thing we looked at is whether the distributions of the gameplay data themselves were correlated with demographics. And again, there were some correlations here. So the correlations to gender were very weak, but there were fairly significant correlations to the way, how people had played the games, whether they were like white or Black. So what this means is when you're imputing the missing values, some candidates are going to be getting, or some groups of candidates are going to be seeing more imputation than others. And if you're imputing to the median of the population, that's not necessarily representative to the median of a particular group. So we did find these causes for concern. The question is, did this actually matter in terms of training and evaluating the models themselves? So what I'm showing you here is a bunch of analysis where we trained models using gameplay data that had all gone through median imputation, but then we evaluated the models for fairness on data that had been imputed using a variety of different techniques. So the blue line here is median, and that's Pymetrics' existing pipeline, right? But for example, the orange line is median training, but Bayesian ridge regression for imputation at the testing time. So the x-axis of this plot is the acceptance threshold. So that's the level at which we would say these are people who should be interviewed versus people who should not be interviewed for jobs. And then the y-axis is the minimum bias ratio, right? So everything above 0.8, we would say meets the 4/5 rule and is good enough. So what you're seeing here is that in all but one case, the performance of the models in terms of fairness is basically the same. Right? Even when you use these different imputations, in all but one case, right, the pink dot all the way on the right at the 90% acceptance threshold, it doesn't matter what imputer you chose. You'd say all of these models are essentially at the same level of fairness. So I think this is a classic case of finding a statistically significant correlation in the data, but when you actually look at the effect size of it, the effect size isn't big enough to really matter in practice. So we thought we had caught them on this, and it turned out that no, actually, we couldn't find anything in the data cleaning assumptions or the way they were doing their sampling that would lead to downstream bias. Okay, so just to wrap up, there's a number of immediate outcomes of this project. The big one is that we would say Pymetrics passed the audit. So for the things we looked at, to the best of our knowledge, they passed these criteria. That said, Pymetrics did improve their machine learning pipeline in a number of ways, just based on the outcome of what we've done. They moved from their median imputer to a much more sophisticated imputer. That was part of a big change they made, where they moved their whole code base from Python 2 to Python 3. They upgraded scikit-learn. So they had a much wider range of imputers they could choose from. They also changed the way that they did some of their sampling for their training and bias evaluation sets. So they added additional sampling criteria for things like language and region and job type. So if, for example, you're recruiting, Spanish-speaking software engineers in Bogota, right, they'll try and sample more prior candidates who speak that language, right, or from that particular region of the world, and that when they played the games, they were applying for a game that more or less matches that job type, or is at least in the same kind of sector. So one of the fascinating things that happened when we released our audit is that there was another audit also on a hiring startup that was released at about the same time. And these audits are a fascinating study in contrasts, right? So we had our audit of Pymetrics, There was also an audit done by Orca. So this is a startup run by Kathy O'Neill, who's the author of Weapons of Mass Destruction. And they were auditing another hiring company called HireVue. They're the one that uses video and audio analytics, right? So you have this kind of video interview, and then it goes through a pipeline, and they predict whether you should be a good employee. So in terms of our audit, I think it's fair to characterize it as a technical audit, right? We were in their data, we were in their source code. That was really our focus. But one thing that we didn't do is any sort of stakeholder mapping. Right? We didn't talk to Pymetrics clients. We didn't talk to people who played the games. And I think that's something we could have done, and that could have informed what we did in the audits. Right? The Orca audit of HireVue is almost the exact opposite. They did no technical evaluation at all. Right? They didn't look at their source code. They didn't look at their data. They asked them questions about their system, but HireVue basically just came back and said, yeah, we're doing those things. In contrast, right, the Orca audit was very much about the stakeholder mapping. So they went and talked to NGOs and civil rights activists and people who had been through the video interview and clients to really kind of inform, like, what are the issues at stake here and what are the questions we should be asking. Right, so in the future, I think a comprehensive audit of this type should really combine the best of both of these. Right, you want that stakeholder mapping, but I think you also want that technical expertise. Right, neither one of these audits actually looked at the end-to-end predictive validity of these products. Right, should you use analytics of a video to predict whether someone is a good employee, right? Or should you use games to determine who is a good employee? Right? Neither audit looked at these issues, and I mean, I think it would be great to have more extensive audits in the future that did get into that. On the positive side, both audits did lead to change, right? So I told you that Pymetrics upgraded their pipeline. HireVue also changed or claimed to change a bunch of their practices as a result of the audit. So the other big sort of takeaway from this project is I think it stands as a sort of new point in the space of auditing as practice. If you look at academic work or journalistic work, like things done at the markup, right, there's lots of people doing permissionless kind of auditing where you're an external person looking at a black box. That kind of work is super valuable. There's always going to be people who don't want their systems to be scrutinized, and it's up to these kind of external auditors to do that. But we're seeing other points in this space being developed. Right? There's a really nice paper from Deb Raji and other people like Timnit at FAT and now FACT 2020, where they talk about internal audits. Right? So this is a process for employees at a company to follow while they're developing things and audit as you're developing. And I think that's super great. I mean, the same way you'd have security engineers embedded in product development, you should have these kind of algorithm auditors embedded in product development as a check on that as it's being developed. Right, so then there's us and this kind of study. Right, I would argue that these kinds of cooperative audits are possible. Right, having external experts given insider access to source code and data and employees, it's possible. We've demonstrated that it can be done, and it can be done in a way that it is, amenable to companies. Right, we did sign things saying we wouldn't release their code or their data. Right, some of your IP, right, it can remain secret, but you can still have an external audit, and it can still be relatively transparent. So only by combining all of these things do I really think we end up in a place where systems are really being thoroughly evaluated in a way that leads to real transparency and real accountability. And with that, thank you for listening. I'm happy to chat and take questions.
Thank you, Christo. Great talk. Very, very interesting. So we have several questions in the chat. Let's try to cover them in the remaining of the hour. So I am Paul asked if you consider that those who were hiring Black females were more predisposed to give a lower score than those who were hiring white males. So did you check at that?
No, so we can't, because like when we were doing our Taskrabbit audit, we don't know who the customers are. And I mean, one other thing that the reviewers pointed out is we don't actually know anything about the quality of work being done. So the implication here is that like some people do better work than others, and that leads to these different kinds of feedback. So I fully acknowledge there are these uncontrolled confounds in the study. That said, on a personal level, do we really believe that like Black women are getting worse reviews because they do poorer quality work than other people? Right? That's crap.
No, that wasn't really the question. The question was, do the people who hire them have a predisposition towards giving lower reviews?
Yeah. So again, I mean, we don't know this.
Okay.
It could very well be, and that would play into this issue of the feedback itself can't be trusted to some extent because it has these social biases baked into it.
Yes, it's something like if you see restaurant reviews, this is completely different, but in Arizona, Mexican restaurants will be reviewed much more strictly than in Boston, let's say. And that's just the region. That's it.
Yeah.
So Sylvia Mir asked if there any way to know whether the features are correlated with protected attributes. I think you checked part of that, but can you elaborate?
Yeah, so we talk about this, it's in the paper. They are. So we very much did the analysis of whether gameplay appeared to be correlated with at least the categories we had data on. And there were statistically significant correlations. So it clearly is important in this case to be applying some kind of bias evaluation, because in the absence of that, those gameplay data biases would very much end up in the models.
Yes, that was my concern. But I guess at some point you ended up talking about this specifically. I guess I thought I asked this before you went into that part. Yeah, thank you.
So let's do a short question, and then I will let the people ask the long questions. I guess it's better. So Gerald McKee asked were the scope conditions of the audit developed in consultation with the Pymetrics, or were decided by Northeastern?
Yeah, this was almost entirely decided by us. So we had some conversations with them about how their products worked, and that informed things like the socio-technical testing that we wanted to do. We wouldn't have thought of that ahead of time because we just didn't understand their product well enough. The only case where we wanted to test something and we ended up not doing it because of conversations with them is we wanted to do evaluation of fairness with respect to intersectional groups. And we could have done that, right? We had gender and we had race and ethnicity, right? We could have intersected them. Their argument against that was, at a moral level, they wish they could do that. And they agree they have the data and the capability to do it. Their counter argument is that doing that might be illegal because intersectional groups they're not named as protected in the EEOC guidelines. And they were very concerned about basically us running a test that they knew they would fail and that they couldn't then act upon. So eventually we decided not to do this because basically I agree with their argument here. We knew the outcome. We knew that they wouldn't pass a test on intersectional fairness because they're not evaluating for it. And I agreed that it was sort of unfair to put this position on them of being like, you failed a piece of the audit and you now can't act on it. But other than that, everything was decided by us.
But Pina has a very short question. Maybe you can answer that first. What is the ML that they're using to power their system? So is that public or not?
I think we name it in the paper. It's random forests. It's just 64 features coming out of the games going into a bunch of forests.
Okay.
Oh, and if I may do a quick follow-up, did they do feature importance? Do you have access to the feature importance?
Yeah.
Do you remember what are the top 3?
Not offhand, but even if I told you, it would lack context because it's all these things coming out of the games. So like you'd have to understand what each game is and then what each number from each game means. The other thing is that the feature importance varies per client engagement per job title, right? Because each client, each job title gets its own model. You know, so for like a salesperson job where risk taking is good, you know, certain features from certain games are meant to capture that and they'll be important. But then for another job where, you know, they care about like meticulousness or whatever, a different aspect of a different game is the psych literature says that's what is telling you that feature, so it ends up being different.
So basically they use different games for different positions, and then you are mixing all the data of these different games.
Yeah, I mean,
another issue that I guess is not explored, right?
Yeah, I mean, so if you read their marketing literature, they say we've drawn these games from psychological literature, and they've been used to measure these higher order concepts like a risk taker or meticulousness or whatever the higher order concept is. And so their marketing literature says, you know, we're evaluating people based on those kind of higher order characteristics. But under the hood, nothing is done based on those characteristics. It's not like this is the game for conscientiousness and the model's training for a conscientiousness feature. It's really just, there are games, they produce numbers, and then for any given client engagement, it's who are the high-performing employees, what games worked for them, and then of the people playing the games, who is matching.
So Will, do you want to ask your question yourself, and you're willing to put your video on if you prefer?
Sure. Yeah. Thanks. Thanks so much. This is mostly just a clarificatory question, and I think I know the answer, but I wanted to ask. So, regarding the circumvention, the adversarial circumvention, on the second way of attackers failing, you mentioned, where Pymetrics succeeds despite this intentionally biased data. This is just to say they succeeded up to the 4/5 level. And so the attacker could still be, you know, making things much worse by maybe a more stringent requirement.
Yeah, that is certainly true. And of course, this doesn't prevent them from accepting a pool of diverse candidates, but then only interviewing and hiring the white dudes anyway.
Right. Thank you. Yeah.
Joe, do you want to, although I think Christo already answered a little bit about intersectionality.
Thank you. Yeah. Thanks. You did indeed give a great answer to the first part of my question. So here I'll just ask you to flex the lack of NDA in your contract when you think about the question. Based on your experience from contract development to technical auditing and now presenting, would you call Pymetrics technically not racist, or would you call it affirmatively anti-racist? Thank you.
I would call them technically not racist. In my opinion, an affirmative stance would be things like intersectional fairness, even though, you know, the law doesn't require it. Certainly not using the 4/5 rule. I mean, they're not even achieving parity. Affirmative would be actually like intentionally saying we want underrepresented people filtering to the top in greater numbers, which this doesn't even approach that kind of a guarantee.
Right. So there were some questions pre-submitted, and I think we have time to answer maybe one or two. One, I think maybe this question is really for Pimetrics and not for you, but maybe, you know, if you can screen for transferable skills.
Sorry, say that one more time.
So if you can screen for transferable skills, so basically how to these characteristics, can they be transferred to the other model? Or?
So I think they do this to a certain extent. When you apply for one job and you play the games, I'm pretty sure they will ask you if you want to opt in to future job opportunities. So if a new client comes along with a new model, they can reevaluate you based on the existing gameplay and say, hey, actually, it looks like you might be suited for this other thing, right? And here's a link to that employer. So it does sort of get at the answer of transferability. At least you don't have to play the games a million times for a million employment opportunities.
So I think that, some of the questions we submitted don't really already answer, but one is more generic, and I think it's interesting and to hear your recommendations. So, what algorithm auditing steps can large organizations take, and to whom should large organizations look for advice?
I think one of the really important things here is to actually do your homework ahead of time. And by that, I mean, if you're developing a product very early on, you need to think about what are the fairness criteria, or what, how does that impact the objectives of this system, and document that, right? What are the fairness or equity or whatever criteria? Why did you select them? And through the development process, how were they implemented and evaluated? Because then if you have someone like me come along, my job is much simpler, right? You've already said kind of what your criteria are, and it's now me double checking your work. I can imagine in different worlds, let's say a company came to me and said, hey, we have this product, do an audit of us. My first question is going to be like, well, based on what criteria? And if they come back and the company says, well, we don't really know, right? We just want to know if this thing is fair in some nebulous sense. I'm not going to be able to do that work. Right now, you're basically put me in the position of having to decide what fairness means in this context, and then evaluating you to that standard, and that's a heavy lift. So to the extent that doing work ahead of time, looking to things like the kind of guidelines we're seeing that coming out already about how to do fair machine learning and how to do oversight and how to do governance, those resources exist now.
Lisa, maybe the last questions. Joel raised his hand. Please go ahead.
Yeah, this has been a great talk. So just to follow up on Joe's point, be helpful to hear you maybe zoom out and say, how do you sort of reconcile the perception within the marketplace that Pimetrics has very evaluative processes, and then you as a sort of the auditor and the scholar know that that's in some way a function of the boundary conditions, right? Not being able to look at intersectionality, or even, I appreciate your note of just focusing on the 4/5 rules as opposed to actual parity. So how do you think about that tension between this is really a win for them in the marketplace, and in your own role as a scholar, knowing that there could be better work in this area?
Yeah, I mean, I'd be lying if I said I didn't have misgivings. I do. On one hand, I really want to encourage companies to be evaluated. And I felt like it was really important to just demonstrate this could be done. So the next time some company is testifying on Capitol Hill and they're like, well, trade secrets and no one can do this work. No, the work can be done, right? That's not a valid counter argument anymore. But then on the flip side, to the extent that we have said this system is now audited, but it's not really fair to a level that I think is sufficient, I mean, that's not great. So, I still think on balance, it was a good thing. And I do really, I appreciate working with Pymetrics. They've been really heavily lobbying for this new law in New York saying that every hiring system must be audited. And that just passed, actually. So overall, I view them as a good actor, which is part of the reason I agreed to this. And if there was a sustained effort to do things like update the EEOC guidelines, I think Pymetrics would be a valuable ally in the effort, because I think they want that stuff too. They just view themselves as being sort of hamstrung. But yeah, I mean, would I do this work for someone else who was not so proactively engaged on these other topics and other aspects of the issue? I might not.
Unless you want to move forward in this field, which is basically your opening. So I think you always will find something that you can do better after you do the first time. So it's natural. So I think you did a great job and you should continue. Maybe you need to ask for a large payment if you don't like it that much. So I'm sure we will work together at the Institute on more interesting and large audits, and also considering the social side, which I think is a very important component too, and that you already mentioned regarding ORCA's work. So thank you, Christo. It was a great talk, and thank you for all the people that attend, and we will keep you posted for the next series that will start in January. So
thanks, everybody. Thank you for the questions.
End of the year. Bye-bye.
Take care.